back. So I've started the recording. So we will look at Python arithmetics. Then we will look at assignment operators, comparison operators. We will look at sequence, the various sequence, list, tuples, and sets. Then also dictionaries. Then inshallah next week we'll look at loops. So in Python we can perform certain calculations. So most often you hear Python as a calculator. So we can perform addition, subtraction, multiplication, division, at least the basic arithmetics that we know. And the symbols or the signs are not far from each other. So for example, we could have a variable say a equal to 10, then b equal to 20. So I'll delete this guy. I'll need a test. So let's say addition. So let's say addition. So if we want to add these two together, we use the plus sign. So a, or let's say sum. Hello dog.
Yeah, I'm with you.
Okay. So we could say sum equal to a plus b. So the plus sign is for addition. So when we print sum, we could have it together this way. Then also we could have subtractions.
Okay.
So similar, we can say answer equal to a minus b. So when we print answer, we are supposed to get a negative value. So print answer this way. Dog, one thing about this particular platform, this Colab, is that it has AI integrated. So you could tell it to do something that you might understand. AI will do it for instead of hard coding it. But they always warn you that you should be careful using the AI. Then also we could make multiplications. We could multiply. So with that one we use the star. So let's say a times b, a times b. Then when we run it, we could have the answer, that is 200. So we use the star to do the multiplication. Now if we want to do division, we have to use the forward slash, a single forward slash. So for example, we could say, let me give it division. We could say a forward slash b, like this, a forward slash b. When you run it, then we have 0.5 as the answer. Then we can perform modulus, that is the remainder, finding the remainder. Then that one to we use the percent sign. So we could say a percent b sorry, b. This way we might get 0.0 or 10. Okay, that's the remainder, 10. Then also we could find the exponent of a particular variable, or powers of a particular variable. So we could say exponent or index, exponent or exponentiation. Let me put this thing there. So with that we could say a, then we use 2 star, so a star star, a star star 2. It means that a power 2, a power 2. If we put a star star 5, that's a power 5. So we want a power 2. Then also we want b power 4. So when you run it, it will give you the exponent. To give you the exponent. Let me put this in a print, because it will print only the last one. So with this one is 100. If I put this, it will print only the last one. But when you put it in the print, you will get the two of them. So this is some of the basic arithmetics that we could work with Python. Then there's another interesting thing that we could look, a very shortcut form. So we will appreciate it more when we get to loops. We will appreciate it more when we get to loops. But there is no harm if we take a glance before we get to loops. So for example, we call something assignment operators. Assignment operators. Assignment operators. Now, we use assignment operators to assign to a value. So for example, I have a variable, let's say var equal to 10. So this is an assignment operator, because we are saying that var, which is the variable, should hold the value of 10. So we are assigning. So sometimes we want to increase the value or the variable by the same value. So there is a technique of doing it. So for example, this is first example. Var equal to 10 is an assignment. We can also say that x plus equal to 3. Okay, we can say x plus equal to 3. Now let me use var. All right, so let me put it in a print statement so that we can get it. So print var plus 3 this way. Why error? var.
Isn't the var supposed to be in quotation?
No, if var is in quotation, that means it will treat it as a string. Yes. Normally we do this to stop a loop. All right.
Okay.
So, yes. So what I'll do is let's do it this way. Let's break it down. So since we have already declared var at the top, so I will say that var again is plus equal to 3. Then we print var, because the variable is being updated. So to take this particular value, so we have 16. Now what this line of code means is that this is a very shorthand form. It's a shortcut form of this.
Okay.
It's a shortcut form of this. var equal to var plus 3.
Yes. Okay.
That's the shortcut form. But this particular var is a new var because anything that comes before the equal to sign is a new thing. But this particular var
Mm-hmm.
is the var above it.
Above the one earlier up there.
Yes. So let me do it this. Let me do it over here. So let's say you have var equal to var plus 3. Okay. This particular var, even though they are
Yeah.
all using var, is different from the var above it, because the rule says that the variable name that comes before the equal to sign is a new thing. It will hold the
Newton.
value.
Okay.
Yes, it will hold the value. So this is how we use to update the variable. So this one is the shortcut form of this. So I'll comment it this way. Then we can do the same thing for all the other operations. We could say that var minus equal to 3. var minus equal to equal to 3. Then we could print var this way.
But you are printing now. Which one will which one is the?
So because I'm working with this cell, it's going to pick the updated var. This one. It will no longer
Okay.
use, yes, it will no longer use this one because this is the most recent updated var. Yeah, so if we want to get the 10, before we do everything, we can still say var equal to 10 so that we get the most, the initial var.
So
Yes,
so
Doctor.
when you print.
So
Uh,
what's the issue?
no, I have deleted my things.
Oh, sorry.
So okay, okay. But you won't specify any var.
um,
Okay, how you print each of them?
yes.
Oh, okay.
Yeah, hello. Yeah.
So you see one of the
Okay,
disadvantage of this
test me.
one. I mean, the online.
Yes, sir. Yes.
When you delete it, it's gone.
The online.
I
I don't understand.
deleted my things. I want to undo. I can't undo.
Control Z and it's still undoing.
It's still on that.
Control and Z at the same time.
Yes, it's not bringing it back.
Make sure your hand is on the. Make sure you've
Yes.
selected the cell. The cell.
I've deleted everything.
Oh.
I've highlighted and deleted.
Yeah, but if the cell is still there, if that particular cell is still there, you can get it back.
Now it's like I deleted the cell too.
Oh, slow.
You don't, no, never mind. Let's continue.
Okay. So
I just wanted to be following.
I wish, but can you type it? I can wait.
No, I am. I will type just the one or two of them.
The last cell.
Yes.
All right.
Yes.
All right.
I mean, let's continue. My internet is slow.
All right, no problem.
Yeah.
All right. So which part? I'm working on this one. So we can do the same thing for all the other arithmetic operations. So for example,
I mean, a quick one.
okay.
If you come to the next one and you want to you print,
Mm-hmm.
how do you run it?
So shift enter.
Oh, okay.
Yes, shift and enter. So we could let's update the var again. So var equal to 10. We do this because it will pick the most recent var. So we
Yeah.
reinitiate the var. So we could say that var, then var multiplied by, we using the multiplication. So we have this,
Okay.
then we put 10 over there. Let me add the comment to each other so that those who will come later will understand. So it's going to be, this thing is same as var equal to var minus 3. Then over here to, we could say var equal to var minus 10. let's put let's put 3 there. Let's make it 3. Then we could print var that way. All right. So the same way we can do to achieve all of them. So I'll skip to the next task. So we will look at comparison operators.
Okay.
Comparison operators. Um, this helps us to compare conditions or two values, and the result is always a boolean. And we all know that boolean can be in a two state. It's either true or false, but cannot be both. So for example, I'll define a new variable again. A equal to 10, B equal to 20, then C equal to 20, right? Now,
Mm-hmm.
I'll go to the next cell, then let me put test cell there. Then we could check, we want to check if it's equal to. So we want to check if B is equal to C. Okay. Now we all know that in basic mathematics, if we want to compare something, we could say A equal to B. But here's the case: we are using it for assignment. So in programming or in Python, if you want to compare, you have to use two double equal to sign. So what I could
Okay.
do is I could say A equal to sorry B equal to C. If I run this, I'm supposed to get a boolean of true, because indeed B is 20, C is 20, and they are equal to. But the moment I put A here, which is 10, when I run it, I'm supposed to get false, because it's not
Mm-hmm.
equal to. So in any cases, in all the cases, if you want to compare, we don't use single quote, we use
Cool.
double equal to sign. Then we can also check not equal to. What is this? We can check not equal to. Okay, so not equal to A, then exclamation, then equal to sign B. So A is, then they are together. There's no space between them. They are together like this. A is not equal to B. It's true. Then we can have greater than. We can have greater than. So we could say that B is greater than A. Then is true. Then we can have less than.
I mean the var. I'm taking us back, but it's okay. The var, the star, the var times equals to 3, for instance.
Yes.
That's supposed to be the variable times 10 times 3. The variable volume 10 times 3, or
So this is the alternative. This is the full version of it. It's supposed to be
yeah,
var equal
times
to var times 3.
3, yes.
Yes. But the shortcut
Which should
is going to be star, sorry, var star equal to 3.
yes, I got that.
Yes.
So that is supposed to give us 30, not so.
Yes, 30.
When you run your own, did you get 30?
No, I had 27. No, I have
You
no,
had
I have 30 now.
my own, I had 39. That's why I'm asking that question.
Eh.
Yes.
I don't know. Can you snap your code and send to me on WhatsApp?
My code is var star, just like this one, man.
The same thing.
Yes,
Are
it's
you sure you
var
updated the
star.
var this way? Do you have var equal to 10 before everything?
Yes, from everything, yes.
Wow.
I have other ones, and it's giving me, I have var plus equals to 3, which should be 13, no so.
Yes.
It gave me 13.
They gave you 13, all right.
It gave me 13, all right. But the var star 3, star equals 3,
Mm-hmm.
gave me 29
No, no.
when I printed it.
So you do you have the same code base of as this? First, you have
Yeah,
var equal to 10.
yes, I have var first, var equals to 10.
Mm-hmm.
Then I decided to have var again. I printed that one, I printed var, got 10.
Okay.
And when I have var plus equals 3,
Is it
I
plus or
printed
multiplication?
plus equals 3.
Mm-hmm.
I printed var and I got 13.
Mm-hmm.
But when I have var star 3
In the
and
same
I
cell. In the
printed,
same cell.
yes, in the same distance, continuation, yes.
Yes, I think that's the reason. So you send me the code, screenshot with the phone, or you are using the phone for the.
I'm using the phone for the class, and I'm using my laptop for the coding. All right, it's okay. Let's continue. Maybe
the reason
it didn't give me error. It
Yes.
just brought the number.
Yes, it won't give error, but it is picking the old var because you perform because they are in the same cell. That's why they divided them. Uh-huh.
But if it is picking the same, it should have also picked same for the second plus x3 plus equals 3.
Was that a different answer? Did you
No, it didn't give me different. It gave me 13.
The expected, that was the expected answer.
Yes, 13, yes.
Wow. Oh, I wish I could see the code.
Nah, for the code is just what I'm telling you.
All right.
I know. Yes, maybe I will send it to a different cell and see what will happen.
No problem.
You let's continue.
All right. So we can also look at the less than. We could say A, sorry, we could say A less than B, then we could have true because A is less than B. Then we could have um, less than or greater than. Less than or greater than. Then we can achieve that by saying A is less than or greater than. So we put them together, no space. The moment you give space, you'll get an error equal to B. Then we can run this that way. Then we can have the last one, which is greater than or less than, or no, later than or equal to. Then I have to update the other one, or equal to, or equal to. So that one to, you make sure, so A, sorry, let's use B greater than or equal to A. Then we can get a boolean. Then we will look at logical operators. Logical operators. So logical operators are used to combine two conditions,
Mm-hmm.
and it also the response of it is a boolean. The response is always boolean. So which is either
Okay.
true or false. So logical operators. So for example, we have three of them. We have n, or, then not, n or and not. So we start with the first one, n. So let me put the comment. So let's start with n.
Okay.
N logical
Operator.
operator. So for example, I could say x equal to 5. Then I'll print it. So print x
X.
is greater than, let's say, 3. N, and it's a small n, no caps. It's a small n. So n, x is less than 10. So with the n operator, um, both condition must be true. Both condition must be true. Whenever we are using the n operator, both conditions must be true. Let me add it. Both conditions must be true. And we use it a lot in programming.
Mm.
Yeah, that's what we use to build login systems. So if the user provide, how do you call it, the email and the password,
Okay.
then we compare, we check, we use the condition to say that if the email is indeed in the database, and also the password is there, and that password at the same time belongs to that user, allow access.
Oh, okay.
Yeah, so if you don't do that, the system will be weak, because
Mm.
maybe um we have the same password, we might be having the same password but different user where we don't even know each other. So if you say that, if you check the system and the password is there, allow the user. It's a real
Okay.
system. So we say that if the user email is there and the same password belong to that email, grant access. So that's another big instance we use mostly in programming. So both conditions must be true. So this is the first condition, which is x is greater than 3 and x is less than 10. You have to get true. Then we have the or logical operator. With this, either one should be true. Either one. I don't know if my grammar is correct.
That's okay. Make the should must.
Okay. Either one must be true. So, for example, let's try this. Print. Since we have already updated, we already have x over there. We can still get access to the x. So we could say x greater than 3, or that one too is also small letters, or x less than 4. We could print it, then we could get our answer. So the condition is that x is greater than 3, which is true, or x is what? Less than 4, which is false. But since we are having at least one true condition, then we are good to go. Then the last one in
Okay.
logical operators is the not. So it's the reverse of if the condition is not true. So we will look at that one. The not operator. So not logical. The not logical operator. So for example, we could print, we could say that x less than 3, and we know x is 5 at the top there, and
Mm-hmm.
x less than 10. So this condition is true because 5 is greater than 3, and at the same time 5 is less than 10. So the condition is true. So we can force this condition, we can make it false by providing not here. So it take the inverse of the n. This way. So we put the not,
Mm-hmm.
it's a function. Then we put the condition over there. So it reverse the n or the or. So without the not, this condition is true. But we put the not, then it will change the condition. Or sorry, it will not change the condition but the results. I hope I'm clear with that one.
So you do that, you get false.
Yes, you
Yeah.
get false. Yes.
Mm.
Then we will look at identity operators. Identity operators, we look at it um, more in NumPy. That is more of mathematics, identity matrices, and those those stuff. So when we start dealing with matrices. So we will look at the next thing, which is identity operators. Then with identity operators, we have only two, which is and is not. Identity operators, we have is and is not. And it returns true if both variables are of the same object. If variable are of the same object. So for example, I could have x equal to a list. Then I'll put, let's say, mango, comma,
Orange,
orange, comma,
guava.
guava,
Mm.
GUA, this way, right?
Yes.
Okay, so I have this. Then I'll copy it again. Then I have y equal to this. Then I have z equal to y. Okay, I hope you all understand the variables. So we have x
Yeah.
equal to a list of fruits. Then y is also having the same element of the list. Then we are saying that z is equal to y. Now, if we print, let's check it before. Let's print z and see what we will get. We get the same list as y and x. So if we print x is z, we are supposed to get true. Is it false?
X is supposed to be Y.
X supposed to be y rather. So let me put
Yeah.
this. Yeah. So it's supposed to be false. Even they have the same content. They have the same content, but they have of this different type. They are out of the same different object.
The objects are the same in the side inside. Or you have mango, orange, guava, mango, orange, guava. Maybe if the arrangement was different, then
So object in a sense of not the element they are looking at. If I put x here, I'm supposed to get. If I put x again, I'm supposed to get true. Even though they have the same element and the same list data type, but they are different objects altogether. So Python is treating this whole thing as a different object, and is treating this whole thing as a different object. Now we call something addresses. So every variable you define is being stored in an address, even if they have the same value. That's
but if you print x is equals to y, will it be true?
So yes. So the difference is, that's a good demonstration. If x equal to y, so we have true.
Yes.
We have true.
True, yes.
Because we are comparing the element by element. So anytime you use equal to, you are comparing the element by element and the data type also. But when we are using the is, it is working at the compiler level addresses, because each one of these variables is being stored in an address and they are unique
No.
addresses. So the moment you delete this variable, it is being deleted from the address. It's kind of more of computer science. That is the compiler, but we will not be dealing much with the compiler. We will be dealing with the surface of it.
So I mean, in this thing you've highlighted. So if you print Z, you are expected to have. If you print Z,
I'm expected to have the values of y,
yes.
but z is in a different address of y in the compiler level, but they have the same members.
Okay.
Yeah, so like what we normally say, that the computer translates um, the stuff to 0 and 1.
Zeros and ones.
Yes, yes, something like that. And they are
Okay.
unique. Each variable is unique from each other.
All right.
Yes. So that is the is. Then we have another one called the is not. So we could say print x is not s is not so s is not x. Then we get false because x is x. But if I put y here, I'll get true because s is not it. Then we look at the last thing before we move. If time will permit us, we move to sequence. So let's look at membership operators. This is very essential. This is super essential. Um,
Yes.
so let me start a new code. So we call it membership operators. Membership operators. Then there are two. We have in and we have not in. So we have in. Let me use small letters. We have in. Okay. So it returns true if a sequence with a value, we specify a value. We want to check if that particular value
Why small letters, please?
can be found in a sequence. So a sequence is basically a list or a string. So for example, I'll go up. I have it in memory. So I could say x equal to then the list that we created. So we could check print, then we say mango in x. So we want to check if mango is among the element in this particular list. So if we can find it there, then the answer is true.
Number of F, right?
But the moment we make a mistake, let's say mang instead of mango, then we get false. So the spellings should be very accurate. So we have true this way. So we can test for Gava.
Meaning Mango is also a member of S, right?
Yes, mango is a member of the list of which is x.
Okay.
And the other type of membership operator is not in. Not in. So let's say not in.
I mean, for instance, if we decide to print it by their index, will it come?
Yes. No. So we want to use the in for the index.
That we are printing instead of we if for instance we want to print the mango
Mm-hmm.
inside X,
Mm-hmm.
but we don't want to say mango,
Mm-hmm.
then we put in place of mango, we put its index.
Okay. So that one we have to write if statement.
Okay.
Yes, but let's try it. We could say if, then we don't want to write mango, right? But
Okay.
we still have to do that. So we could say that if x, then we want to this is not we want to find the index. So square bracket. Then the index of mango is, we know, is what?
0.
0. Hey, where is my? Hey, I can't find that guy on my keyboard. Sorry. So 0. If x 0 is equal to, then we still need to put mango there. Mango.
Yeah.
Then colon. Then we could print let's put something true. Now I made a mistake here. It's supposed to be in. No, it's supposed to be equal to. So we are saying that if the position 0 in the list is equal to mango, print true. Then let's add our else statement like this. Then we could print
Okay.
false this way. So when we run it, we have true.
Okay.
Yes, we have true over there. But here we didn't use any of the in. So what we can do is we could make it is it comparison or multiple conditions. So we can say and also something will come, not just one condition. And for example, I put this. So I have something like this. I'll still get through. Yes, because both conditions can be satisfied. All right. So give me the question so that I can comment it, so that when I share this with you and we are doing revision, you might know why we did this code.
I said if instead of printing mango, you want to print, you print the index of it.
Okay.
Will you get mango?
Get the index of the mango. Yes. So anytime it's a sequence, you can get, even if it's a string, not a list, you can still get it. So let's look at not in, example of the not in. So we still maintain the list above. Then I could say that print we don't have pineapple in inside, so pineapple not in the list X. So when
I mean, but why is but you sorry, But you should know that, like, if you are, for instance, I in the previous code cell,
Mm-hmm.
I say, I mean, on this platform, then I use X.
Mm-hmm.
If you print X, for instance, the earlier one we use maybe X is equals to 5.
Yes.
I come down, I print X will give me 5. And now
Yes.
if I come to the membership operator, for instance, then I decide to use X again and
Mm-hmm.
put the members inside.
Mm-hmm.
I'm printing, it may go and pick the first 5 no for me.
So what you have to understand is that if I have a variable
Mm,
here equal to 10,
yeah.
then I come down in any way whatsoever, then I define x again and say this equal to 90. We are no longer getting access to this 10 again. This one will override it. So what you have to also understand is that the programming, it starts running from the top.
I try to, uh-huh.
So it start running
Well,
from
it's
the
still
top.
giving I described. Oh, okay.
Yeah, it start running from the top. So it will run. So when you get to here, it will replace 90 with 10. So this one is going to be the most latest.
Yeah, but I expect that if you are printing, for instance, because you kept these are in different. My case, I have them in different code cells.
Mm-hmm.
Like this one, you come into no, not like that,
I want to.
not this way,
Okay.
not this way. Aha, like you start another coding, then you say x is equals to 90.
Okay. Another cell
Yes,
like this, then I say s equal to, let's say,
90 or x equals to. Then you print from here x.
yes, I'll get 100. I'll not get 90 because this is the
And
most.
my own, yes, but my own is misbehaving.
Yeah. So one thing is that always go back and run the cell and before you come to the next one.
Mm, okay,
Yeah, when it's doing that way, go back to the previous cell, then you run it before you come to
all
the
right,
next one. Yes, sir.
all right. Thank you.
You're welcome. We will look at one thing which is very very important. Everything is important.
Mm,
So order of precedence, more or less like board mass.
Okay.
Yes, more or less like board mass. So whenever you want to make certain calculations, some will come before the others. So in the order is parentheses will come before exponents. Before exponents, then if there is any shorthand, the shorthand, that's the assignment. These ones.
Yeah.
Let me come. Okay, let me demonstrate it here. This one will come first. Parentheses will come first. Then exponents will come. Then if we have assignments to, let's say, plus 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 equal to, those ones we can have multiplied equal to, that way. So this one will also come. Then multiplication followed by division followed by modulus. Then let me modulus. Then we have this plus plus and minus, they have the same level. So this is the order of precedence in Python. So we will take some few demonstrations. I'll share a link, then we can look at it. But parenthesis has the highest precedence. So for example, I could say print. I'll do it straightforward. I'll not assign any variable. Print 6 plus 3. Okay, then minus 6 plus 3, this way. Now parentheses have the highest precedence and need to be evaluated first. So first of all, this one will be calculated separately. Then the answer is supposed to be 9. Then we have another one, because this one is also in the parentheses. We have 9. Then 9 minus 9 is equal to 0. So let's see. Yes. So 9 minus 9 is equal to 0. So multiplication also has a higher precedence over addition. So for example, if I have something like print 100 plus 5 multiplied by 3. So first of all, what we expect is that we are going to have 5 by 3, 5 times 3, which is going to give us 15. Then we add 100 plus 15, then we have 150.
150.
Yes. So that is the order of precedence in Python. So I think any questions so far?
For me, no.
Okay, that's fine. Dog, any question?
My questions are my own. Yeah, I'm jumping ahead, so there are no questions.
Oh, but if you want us to look at it together, we will look at it.
Nah, I jam my head on something, but it's not on that. For today's class, I'm okay.
All right, all right. So I've also recorded it. I will upload it right away and share
Okay,
the slide, this one with you also.
that's fine.
Yes, yes. Okay. So I'll end here. Assalamu alaikum.
Walaikum salam. I mean, how my my Anaconda, how are we doing it?
Aha.
Are we calling phone or we are doing it online like this?
Yes, let's we do it online like this.
Okay.
Yes. Let me end this particular.